What's up? It is Monday, September 23rd, 2024. We're going to do a lot of reviewing. You see that it's going to be note-taking time at some point in there. Look all the way down there. Hey, Taylor Swift says, if you fail to plan, you plan to fail. Strategy sets the scene for the tale. I don't think she's the first person to say this. I like that second part. Strategy sets the scene for the tale. I really like that part. However, Benjamin Franklin did say, if you fail to plan, then you plan to fail. So you always want to make sure to have a plan. So I'm like, hey, go back and check your first trimester goals. Go back and check your first trimester goals. What was your plan? Are you working the plan? So as I've been going, I've been challenged with a whole bunch of new things, and I've been having to try and come up with systems or plan to take care of everything. If you take a look down here, I just want to make sure journal check number 4. It is due on the 27th, so that is this Friday. We will have a journal check, and then first month of school, the final draft is due on the 24th. That actually, it's not going to be on the 24th. Hold on, pause. Okay, we got everything together. It will be due on the 25th. So the 25th, that is Wednesday. And then I did want to say this Explore 1. I went through and I messaged everyone who has still not turned that in. I haven't started grading that. I am a little bit behind as far as grading that because I was grading other things first. However, I do just want to make sure that you guys got that. So make sure that you've got this in there and you've got that turned in, okay? So I message people who have not turned it in yet. I will start grading that one tomorrow. Again, I'll start grading that one tomorrow. All right, cool. Let's keep it pushing. How was your weekend? Hopefully it was well. I will say I played a lot of Minecraft this weekend. Maybe I played too much Minecraft. Also hard to sleep last night. Yeah, so my weekend was cool. And then now I'm tired. But, hey, it is what it is. Como estuvo tu fin de semana, right? So, hopefully you had a good weekend. Hopefully your weekend was well. You can leave me a comment. Let me know how your weekend was. Okay, let's keep that joker pushing. All right, so we're just going to take some time to review the quiz and take a look at that. So if you have any questions, go ahead and look through the quiz. Let me know if you have any questions. There's probably 1 or 2 questions that I do want to go over. So let's take a look at them right now. Okay, let's look at these 2 questions right here. Let me move Missy F, move out the way. Okay, so this first one, Mr Farr ran, we got to do this, huh? Bop, and then turn into a pin. So Mr Farr ran a 200-meter race, and it was at 25.81 seconds. What was her average speed? So we've got to find average speed. Here's the formula for speed. Speed is equal to distance divided by time. Or you could let's write that down here. Speed is equal to distance divided by time. And this was just a substitution into the formula. So here is the distance. 200 meters. So I'll put 200 meters on top. Cool. And then there's the time right there, which is 25.81 seconds. Now, where people got it twisted was make sure to round to 1 decimal place. So there's an example, 0.1, and only enter the numbers in the box. That's how we got to 7.7. We're going to talk about that right now. So let me get the calculator going, get that calculator. And then, so 200 divided by 25.81, right? Cool. When we actually do that, it works out to 7.7. And if you look right here, 5 or more up the score. Hey, 4 or less, which is what we have. We have 4 or less. Let it rest. Okay, so then that means that it should be 7.7. That's what you should have entered in, just like you see right there. And it should have been meters per second. Hopefully you guys saw that. Okay, then let's go on down to this one right here, which is convert the weight of a 9-pound pumpkin to newtons. So remember, where are we going on this trip? We're going to newtons. That means newtons should be on top. So 4.45 newtons over 1 lb times 40 point. Oh wait, what am I even doing right there? Hold on, let me just erase that. Whoops, give me the eraser instead. Oh my gosh, can I not erase? Can we not erase right here? I don't want to erase all. I just want to switch to the eraser. Oh my gosh, this is taking forever. Can we not erase? Oh, we just have to make it like that. It is what it is. So we'll put this over here and say, oh, it's a 9-pound pumpkin. So we'll put 9 LB over 1. And then that ends up being 4.45 times 9. But we're going to get rid of the LB, cancel the units. And then now we just have 4.45 times 9. So let's bring that calculator back one more time. One more time for the one time. So then 4.45 times 9 is equal to 40.0. And again, 5 or more up the score. We need one decimal place. Again, one decimal place. So it should have worked out to be 40.1, right? Because if we have this 40.05, that's what we got out of the calculator. Right here is where we're going to get that one decimal place. That ends up being 40.1. And if you want to get technical, and I said don't enter the units there. However, it would be 40.1 newtons because that's what you see here. Okay, cool. So I just wanted to go over those two questions, make sure we're good with the math. Hopefully you guys are like, okay, I get it. I get where I went wrong. Okay. If you do want to do a retake, okay, we do have an option for you, okay. Now here's how this is going to work. If you want to do a retake, you have to take the retake quizzes. It is a little bit longer, a little bit more questions to kind of help you out with the studying. You must get an 80% to retake. One person, an 80% or above, 80% or above in order to retake the quiz, because that's how you're going to show me that you're going to study and put some time in answering questions and looking at answers and making sure that you're ready to go to retake the quiz. So there's one person two people asked me to retake the quiz. One person already retook this. They got like an 89%. So they're going to retake the quiz today. Okay. But if you want to retake the quiz, you can come in during lunch. You can also come in before or after school if you like. Most people would prefer lunch. Or there's also going to be a study session for the quiz on Tuesday if you feel like you need help. And then there's also going to be a retake time on the quiz on Thursday, and Miss Silvera is going to be the one who's doing that. So you'll see that on there. So look for Miss Silvera. She will have the retake for Mr. Farr's quiz on there and a study session for it on Tuesday. Now, I do also want to point this out for the people. Okay? I want to point this out for the people. Okay. If you got 14 or below, you should retake this quiz. You should study and retake. If you got 14 or below on the quiz, you should study and retake. I just want to get that out there to say that's because mastery of this subject area for this quiz is 15 points. So again, if you got 14 or below, study. Take some time to retake that thing. I know sometimes we like to just push forward, but I'm like, no, take some time to retake that thing. So again, go retake that quiz is number 2. Get an 80% or above. If you got to take it a few times, it's unlimited retries. It's not a big deal. And then that way you can get yourself ready and then retake the quiz at some point during this week. All right, y'all. Let's move it along. Okay. So for I'm not going to go over all of this because I went over this on Friday's lesson. So on Friday's lesson, when we went over all this, there's a few classes that are a little bit behind. So I'm going to reteach this for some of the classes that are behind. But for everyone who's on here, I already taught this on Friday's lesson. So we're skipping all the way ahead. And basically, we were looking at Newton's law of just saying, hey, for every action force, there's an equal and opposite reaction force. And just walking through the lab and seeing, like, what did we actually witness in the lab? All right, now I want you to turn to page 11, 10 and 11, okay? And I want you to retry both of them. So, again, go to pages 10 and 11, and retry both of them, okay? You'll do the middle portion on 10, which is during instruction, because that's about where we're at. And during instruction, you're going to answer that question. Why does it hurt to kick a soccer ball with your bare foot? See if you guys can maybe have a little bit of a better answer. We'll talk about that, and then also try and fill out this. So pages 10 or 11, okay? Fam, did you really pause the video? Did you go do pages 10 or 11? Because if you didn't, you need to do that right now. Don't be trying to be like, oh, I'm trying to skip ahead and get the answers. No. Use your brain. Use your brain. All these times, these are practices, right? To do some active memory and see what it is that you think, and then we'll compare it to the lesson. That's what we had. So this is an opportunity. So please do so. Thank you very much. Pause the screen right now. Pause. Okay, let's walk through this. So hopefully you guys are at this point where for every action, right? For every action force, there is an equal and opposite reaction force. So hopefully you were able to get that in there, right? Forces always act in, and maybe if you could see, if there's an action force and there's a reaction force, that means forces act in what? Two things, pairs, right? So forces always act on objects. So forces act on objects, right? So they're acting on something. So the forces act on objects. They work in pairs and are measured by, hopefully you're cool with this, newtons. Yeah. So hopefully we got that. Forces can be, right, direct contact. And what kind of direct contact forces do we have? And then what kind of at distance forces do we have? So just think about those ones. We're not going to talk about that too much, but hopefully you got at least this top part. Now, why does it hurt when your foot when you kick a soccer ball with your bare feet? Hopefully you're getting that picture of action reaction forces. So the harder I hit something, then the more that thing will apply an equal but opposite force to my foot, right? Or to my hand, or to my whatever. Like when we slap the table, or when you kick the soccer ball. There's an equal and opposite force. And that pain, right, that we're feeling or receiving, that is, right, that force being applied back to our hand. Number two, let's look at this though. And this is a question I'm not going to answer just yet, but I'm going to ask. Then why does the soccer ball travel so much further than your foot does? Like if the same force, equal and opposite forces are both being applied to the foot and the soccer ball, and they're actually, if you think about it, at first they're like this, but then they start moving in the same direction, the soccer ball and the foot. Why does the soccer ball travel so far and your foot does not? So we got a couple things to think about there. Okay, cool. Let's keep it pushing. Let's go with this. Can you find the pattern? I'm gonna give you like. What's the pattern? Okay, so it says 9, 14, 27. Hold on. Wait a minute. And then 28. And then, so we got 9, 7, 14, 18, 27, 21. So this is separated by 2. This is separated by 4. This one's separated by 6. So the difference between these two should be what? Hopefully you got it. LeBron James. LeBron. No, it's 36. It's 36, yeah. So that is the pattern. I know it's a crazy looking pattern, but hey, just try to get you thinking a little bit. All right, let's keep it moving. Guess what time it is? Everyone say it. Note-taking time. Let's go. Okay, so go ahead and get this in your picture vocabulary. A spring scale is a tool that measures a pulling force by the tension of a spring in the units of Newton. Again, a spring scale is a tool that measures a pulling force, right? Because it's pulling it down, right? By a tension on a spring in the units of Newton. Now, you've used this at this point twice, so you've kind of seen this in action. You kind of know what it looks like. You know how it works. Totally cool. I'm going to skip to the next slide. If you still need this note, go ahead and pause. So pause as you need the notes, okay? All right, next thing, we've talked about this as well. Newton is a unit of measurement for force. So any force is measured in newtons, and we connected that thing to say weight is a force, and it's a measurement of the force of gravity pulling down on an object, right? and we measure that in newtons because it is a force. Again, pause the screen as you need that, okay? Cool, on to another one. So this is another word that we've used. We use the word collision. So we're just going to talk about collide. So collide or collision is to strike or hit something with any amount of force. So the amount of force does not matter. This is a collision. This is also a collision, right? Those both collisions, the amount of force does not matter. What's mattering is, are these objects coming into direct contact? Boom, it's a collision. Okay, so let's just make sure to get that right. Okay, let's keep going, and I think that's exactly where we're gonna end. We'll leave that for later in the week. Okay, cool. So that's exactly where we're gonna end, and love y'all. Peace.